Have you ever really, truly looked at your computer? You know, that box of metal and plastic and silicone sitting on your desk? And have you ever wondered what actually breathes life into it? What's the magic that turns this lifeless object into a tool that connects us, helps us create, and, calculates at lightning speed? Well, let's pull back the curtain and uncover that magic together.
So let's think about it like this. You've got all the physical parts you can see and touch. The processor, the memory, the screen, all of it. That's the hardware. It's pretty much the physical body of the machine.
But a body without a mind, without any sense of purpose, can't really do anything, right? So what's the invisible force, that spark, that gives this body a soul?
Well, the answer is software. It's that invisible set of instructions that turns a really powerful, but let's be honest, an otherwise pretty dumb machine into the incredible device we all rely on every single day.
Okay, so to really get a handle on software, we first have to talk about its other half. Let's start with the body, the hardware.
Think of the hardware like a supercar engine. Your CPU can perform billions of calculations every second, which is just mind-boggling. But without a driver, that engine just sits there. It has all this incredible potential, but absolutely no direction. On its own, hardware is just a collection of parts, literally waiting for instructions.
And that, of course, brings us to the soul of the machine, the ghost in the shell, the software itself.
So, what exactly is software? It's not something you can physically hold, right? It's a collection of instructions, code written by programmers that basically acts as the mind for the hardware body. It's the command center that gives the computer its entire purpose.
And, just like our own minds, software operates in a couple of different levels. A good way to think of it is this. You have the subconscious part. That's the system software, like your operating system. It's always running in the background, managing the basics like memory and processing power, kind of like how your brain manages your breathing without you thinking about it. Then you've got the conscious part, the application software. These are the programs you choose to use, like your web browser or a photo editor.
And believe me, that subconscious system software is doing some serious heavy lifting. It's basically the air traffic controller for all your computer's resources, making sure everything runs smoothly. It also gives you that visual interface, all the buttons and icons we click on. And it uses these special translators called drivers, so your computer can talk to your printer or your graphics card without any hiccups.
Okay, so we know what software is, but how does it happen? How does a human idea turn into an instruction that a machine can actually follow?
Well, believe it or not, it all starts way before a single line of code is written. It starts with logic. A developer needs a plan.
And that plan is called an algorithm.
The best way to think about it is like a recipe. Seriously, it's a clear, step-by-step set of instructions for solving one specific problem. It's the logical blueprint that exists completely separate from any programming language.
And here's a super simple example of that logic in action. If you want to compare two numbers, the steps are pretty straightforward, right? First, get the first number. Second, get the second number. Then, check if the first one is bigger. If it is, say so. If it's not, then say the second one is. This clear, unambiguous logic is the foundation of all software.
Okay, so we've got our logical recipe, our algorithm, but that recipe is written in a language that makes sense to us humans. Now we face a pretty big problem. How in the world do we teach the machine to read it? And yeah, it is a huge problem. We think in words and abstract concepts. Computers, they think in electrical signals, on or off, 1 or 0. That's it.
Just look at the difference here. On the left, you've got a high-level language. It's clean, it's readable, it almost looks like English. On the right, that's machine language, pure binary. And that's the only thing the computer's processor actually gets.
So, to bridge this massive communication gap, we need a special kind of translator program, something that can convert our human-readable instructions into that machine-readable binary code.
Now, there are two main types of these translators, compilers and interpreters. A compiler is like translating an entire book at once, then handing you the finished translation. It's a lot of work up front, but the result is a separate, super fast file. This is why a complex video game, which is compiled, feels so instantly responsive. An interpreter, on the other hand, is more like a live translator at the UN. It translates your code line by line, on the fly. This is common with websites and scripts. It's more flexible, but sometimes feels a little slower because the translation is happening as you use it.
Okay, we have our hardware body, our software soul, and a translator so they can communicate. But every program needs something to work on, right? It needs raw material to process. So what is that raw material?
Yep, that raw material is data. Just like a chef needs ingredients for a recipe, software needs data to process, to organize, and to transform.
And the key difference here is all about context. See, data is just a raw, unorganized fact. The number 42 all by itself means absolutely nothing. But when software processes it and adds that crucial context, the current temperature is 42 degrees, suddenly it becomes useful information. And that transformation is where the real magic of software happens.
So let's just recap our journey really quick. We started with the physical hardware, the body. We gave it a purpose with software, the soul. The blueprint for that soul's logic is an algorithm, which is then translated into a language the body understands. And finally, that software works its magic on raw data, turning it into valuable information.
This whole process, from silicon to soul, has completely defined our modern world. And it leaves us with a pretty fascinating question to chew on. As software evolves with AI, which can learn and adapt on its own, are we no longer just writing instructions? Are we, in fact, programming a fundamentally new kind of soul?